All right, hey, what do we do first for the division problem?
Put one in a box.
One in a box, you guys agree with him?
I don't know.
Caleb know what he's doing?
Maybe you would know if you did your homework. Hey, don't be like that. Don't be like that. It's not cool, man.
All right, so you guys all agree with Caleb? Put the one in the corner box?
Everyone should agree with me.
All right, he is correct, that's right. All right, so remember, whatever makes this equal to 0 is what you put in the corner box, right? Basically, it's the opposite of what you're looking at, right? Now, I have to put a 3 in for the x cubed, a -5. For the x squared, what's missing? An x. So what do I put in that spot? You got to put a 0 in that spot, right? Just like we had to do for the long division. And then the -2 for our constant. Okay? So that's a mistake we sometimes make because we get in a hurry. All right? So remember, this has to go down by 1. So you got to the third power to the second, we don't have the 1 to the first power. So we have to put a 0 in that spot. Then we make a line, leave ourselves a little room under these numbers so we can put numbers there. Drop the first term, and that's how we get it set up to start our synthetic division problem. Any questions? You guys that weren't here. Okay. Now, we multiply 1 times 3 and put that answer under the next number. And then what are we supposed to do with those two numbers? We're supposed to add them. Okay? Long division, we subtracted after we did the multiplication, right?
Yeah.
But for synthetic division, after we do the multiplication, we do addition. So -5 plus 3 is a -2. And then I go 1 times -2, put that under the 0, and then again, I add those two numbers to get -2 down here again. And 1 times -2, again, is -2. And then I add those two to get -4. This number is our remainder in our synthetic division. Okay? So our answer is written, okay? It started out as x cubed right there, right? In our answer, it's always 1 less the exponent, okay? So our answer is 3x squared minus 2x minus 2, and then that's our remainder. So our remainder plus, and then we put -4 over, what were we dividing by? X minus 1. So that's the answer. Instead of doing it long division way, using synthetic division, which is a lot quicker for us, right? Questions? It's pretty easy, right?
Yeah.
Okay. The second type of problem, it says use synthetic division to evaluate. Okay. So,
If we just put like -4 over x minus 1.
that's okay. Yeah. All right. When it says use synthetic division to evaluate, okay, this number is the one that goes in the corner. You don't do the opposite like the x minus 1 up there. It says x equals 6, so you actually put the number 6 there. Okay? Then we do everything else the same. All right? So I put a 1 in for the x cubed. What's missing? X squared. So I got to put a 0 for the x squared. And then -6 for the x, and then our +1. All right? Everything else is the same. 6 times 1 is 6. 0 plus 6 is 6. 6 times 6 is 36. Negative 6 plus 36 is 30. And 6 times 30 is 180. So 1 plus 180 is 181. All right? Now, when it says to evaluate, okay, we're looking for a number answer. Okay? Our number answer is whatever the remainder is. So if we did f of 6, the answer is 181. If I were to put a 6 there and a 6 there and do the multiplication and simplify it, it would be 181. It's just a different way to evaluate a function. Okay, so those are 2 types of problems we had for homework and that you'll have on your quiz. When's your quiz? Thursday.
How many long division questions will be on?
Just one.
Okay.
All right. So homework answers. All right. Number 9 is x plus 12 plus 49 over x minus 4. We did the odd, right?
Yeah.
Number 11 is 2x minus 11 plus 62 over x plus 5. Number 13 is x squared minus 3x plus 5. And then again, if you want to write it like Sydney asked, you could write minus 9 over x plus 3 because it was a negative 9 for your remainder. If you want to put plus negative 9 over x plus 3, that's okay also. And then 15 is x cubed plus x squared minus 2x plus 1. And then our remainder was negative 6. So you put minus 6 over x minus 6. Any of those you'd like me to do?
You repeat 15?
X cubed plus x squared minus 2x plus 1. And then minus 6 over x minus 6. We're good? All right. And then we jumped over to 24, right? 24 is 13. 26 is negative 27. 28 is 903. And 30 is negative 752. Any of those you'd like me to go over? Sure. Bless you. Jordan?
Oh, I was wondering if you could go over 28.
Okay. All right, I'll go 28 and 30. We had questions on those. All right, so remember, it says for 28, x is 10. And then we have a 1 for the x cubed. There's no x squared. Negative 9 for the x. And negative 7. So make sure you add your 0. So 10 times 1 is 10. 0 plus 10 is 10. 10 times 10 is 100. Negative 9 plus 100 is 91. 10 times 91 is 910. Minus 7 is 903. That's our answer.
28?
That's 28, yeah.
Here, I see where I went wrong.
For 30, x is 5. let's, quiet down a little bit, please. -1 for the fourth, -1 for x cubed, 0 for x squared, and a 0 for x. And then the -2. We gotta go down in order and hold those spots, okay? And then drop a -1. So 5 times -1 is -5. When I add those, I get -6. My sleeve hit that. 5 times -6 is -30. When I add those, I get -30. 5 times -30 is -150. So when I add those, -150. And then 5 times -150 is at -750. I think that's right. When you add those, it's -752. Caleb?
What purpose does a remainder hold in the problem? It's like afterwards, it just kind of like.
It's a different way to do this problem if I just did this. Here's what we're used to doing. Oops. It's a different way to evaluate a function. So it's, instead of doing this, instead of doing that problem, you could do this problem. The remainder is the answer to the problem if I substituted a 5 in.
Oh, okay. I thought it was just kind of useless features.
They're just showing you a different way to do the same type of problem.
Why should
Okay. Anything else? All right. So today I have a practice quiz for you. And we'll go over that tomorrow, and then our quiz is Thursday. All right? So you got lots of time. It's not that difficult. I'm expecting good grades Thursday.
Fortunately.